pi over 2 is in the domain. Because sometimes if this constant is not in the domain, we will not be able to apply the theorem. But in this case, we could apply because pi over 2 is in the domain, right?
Yes.
That's something we will, have that kind of a problem. But this one is fine. And so, yeah, so your answer was right. So that's, oh, hold on a second. You're still missing something else, actually. Oh no, it's not. You're not. You're not. That's good. That's good. I see. Okay. All right. Okay, good. Next one. $26. Karen, right?
Yeah. So the first thing we're going to do, since this equation is the absolute value, is that we have to find whether the value is positive or negative on what parts of the interval. So you set the inner equation to 0, you get rad x equals 1, and then you just find 0 and it's plus or minus 1. But since the interval is 0 to 4, you reject 1 since it's not in that domain. And then you just put it on the number line. I think I use 0 for the left and then 2 on the right. And then you can find that the values are positive when x is greater than 1, and the values are negative, or not negative, negative when x is less than 1. And then you just split it up into intervals where from 0 to 1 it's 1 minus rad x, and then from 1 to 4 it's rad x minus 0 since it's negated. For the left equation, I just did x minus and then the x to the n plus 1 over n plus 1, which should be x minus 2 over 3, x to the power of 3 over 2. And then you just take that, find the values where x equals to 1 minus where x is equal to 0. And that should be 1 minus 2 over 3 minus 0, and that should equal to 1 over 3. And for the right equation, it's the same integral, except it's just negated. So it's 2 over 3 x to the power of 3 over 2 minus x on the interval of 1 to 4. And then just 2 over 3 times 4 to the power of 3 over 2 minus 4 minus 2 over 3 minus 1, and then that should equal to 5 over 3. And then just add the two numbers since it's the sum of the areas, and it should equal to 6 over 3, which is just 2.
Okay, looks great. Anyone has any question? Yeah, this is about absolute value. The integral is absolute value, so we have to check for the split into intervals. All right, great. If no one has questions, perfectly done. Thank you, Karen. Let's see, who's next? Yeah, Noella, yeah, nobody do 22 yet. Get that 22.
Professor, it's Amir here. So okay, so for question 31, we're given y is equal to a definite integral from 2x to 3x plus 1.
You mean, hold on a second, you mean 32, right, Amir?
Yeah.
Yeah, okay.
I'm just rewriting quickly. And then we're given here sine of t to the 4th power dt. And then what we're asked to do is find the derivative of this. So what I did was I actually tested, like I said we could have a value in between these two values, as in c. So what would happen then is we would have here c to x, the definite integral from 2x to c, and then all of this sine of t to the 4th power dt. And then plus the definite integral from 3x plus 1 to c. I mean c to 3x plus 1. And then from here, we're usually used to seeing x on the upper bound. So what we can do from here is we can use a negative and switch the boundaries. So from here we would have here 2x c, and then sine, same thing basically. And then from here, all I did was I took the derivative. Wait, I forgot the negative right here. So
Let me ask a question. Oh yeah, right. Right. You forgot the negative sign.
okay, and then from here, what I did, all we're doing for each of these, we're taking the derivative of the upper boundary and then multiplying that by basically the upper boundary substituted into the equation. So from there, we would have your the derivative of 2x is 2, and then we would have a negative 2 here, and then we would have your sine. Okay, so you have your negative 2 sine of 2x to the raised to the 4th power, which is 16x to the 4th power. And then for this side, we would have your the derivative of 3x plus 1 is just 3, and then you would just substitute 3x plus 1, so you get 3 sine of 3x plus 1 raised to the 4th power. And that's our solution.
Yeah, great. Anyone has any questions? You know, this is like a typical exam question, right? To apply fundamental theorem of calculus, this lower limit also involves x. So we need to split this one. The upper limit involves x, lower limit involves x. So both upper limit and lower limit are functions of x. But we need to apply the theorem, we need a constant as a lower limit. And so we just see, okay, let's see, be in the middle of from 2x to 3x, in the middle of 2x, 3x plus 1. Then we split into two integrals. Yeah, then just go from there. All right, anybody has any questions? All right, okay, great work, okay, Amir, thank you.
Asked to evaluate the integral from 0 to 3 absolute value of x squared minus 4. We know x squared minus 4 factors into x plus 2x minus 2 because squares, are squares. And then we can mentally check that it goes using the number line thing. So we plug in a value less than and greater than, and we see it goes from negative positive, so we can use 2. Then we can split the integral up into 2 parts from 2 to 3 and 0 to 2. And we know that 0 to 2 is going to be the negative version of the function. So I got it from negative x squared minus 4 parentheses. I just distributed the negative, so I got 4 minus x squared, and then I just evaluated the integral and subbed in all those values from the bar and got 23/3.
Okay, yes, again, the integrand is absolute value. So I have to check when it's positive in the integral. Okay, great. So it's split from 2 to 3 and 0 to 2. All right, yeah, nice. Thank you, Kaiser. If anyone has any question, feel free to to jump in to ask questions. All right, next one. Angel, we see your work here. We see your screen, but we cannot hear you yet.
Hello?
Yeah, we can hear you now.
Are you able to see my work?
Yeah.
Oh, because I don't see it.
Oh, okay. We see it.
I'm gonna start even if I don't see it. I'm just gonna use my notes.
Yeah, you see your own screen, right?
Just now, because my internet's slow. Okay. So first, for this question, we are asked to find the derivative of the function. First thing I do was split the integral into 2 and then take their derivative. The one is from radical x to a, and the other one is from a to x. And then I use substitution. We use u equals to x and then find du over dx equals to 1. And for the other one, we use u equals radical x and then find d over dx to be 1 over 2 radical x. And then we use part 1 of the fundamental theorem of calculus to find the derivative of the function. Since it is continuous in the given interval, the domain of the function is x is not equal to 0, so we assume a is not equal to 0. And then I took the derivative of the integral and found negative signs, negative cosine u over u for the first one because I switched the lower limit and the upper limit. And then I substituted back radical x and x for u, and then multiplied the first result by 1 over 2 radical x, and then the second one by 1. And then I simplified and got 2 cosine x minus cosine radical x over 2x.
Okay, looks good. But I think you should have a minus sign since the third line. right? You should have a negative sign here, starting from here.
Oh.
Because you switch the.
Oh yeah, I switched in that part.
You switch the limit.
Mm-hmm.
Great. Looks
Thank
great.
you.
Okay. Thank you. All right. So I have okay, Noella 22, right? Okay, well, we'll wait for her. I mean, oh. Yeah, we see a screen, Noella.
Oh,
Yeah, we can hear you now.
okay, so for number 22, we were asked to evaluate the integral of variance s. So in this case, I let u equal to 1 plus tangent t. So du would be secant square t dt, and dt, if we move du and secant square t to one side, it would equal to du over secant square t. So in that case, we plugged it in. We plugged in dt as yeah. So we would so the integral would be u cubed times du, and the antiderivative of that would be u to the fourth over 4. And then from there we could plug in u, substitute u, so it would be 1 plus tangent t to the fourth power over 4. From there, we plug in the interval, we plug in the values that we were given using the interval 0 to pi over 4, and we subtract f of b from f of b minus f of a. So we would get 2 to the fourth power over 4, which simplifies minus 1 over 4, which simplifies to 15 over 4.
Okay, only one question, similar to before.
Mm-hmm.
Here you divided by secant square t.
Yes.
Can secant square t be 0?
No,
Why not?
because denominator cannot be 0 because it would be undefined.
Oh, well, you made a denominator. That's right. But secant square t can be 0. Because t, right?
Mm-hmm.
In general, because t can be any number in between of 0 and pi over 4.
Mm-hmm.
Will secant square t ever be 0? Maybe not in this integral, but in general, I wouldn't suggest this method. Look at this.
Okay.
You already have secant square t dt. You already have here.
Mm-hmm.
You just substitute this into du, right?
Yeah.
You don't need to divide, because whenever we divide by a variable involved, we may make mistake because that term might be 0.
Mm-hmm.
So only if the term is not 0, we can divide, because we cannot divide by 0. So for this, we don't really need this line. You have du secant square dt. Secant square t dt, you just substitute into du.
Okay, thank you.
You're welcome. Okay, good. All right, so this Noella. I think we finished presenting, right? Okay. So if nobody has any questions, we're going to chapter 7, chapter 5, chapter 6. It's not included in this course. That will be in 155. So I'm going to talk about how to use this integration. So we're going to talk about how to get an area of this kind of shape and even volume. So we can talk about the volume and the area of a region. So let's see this one. So we have a shape like this. The left-hand side and the right-hand side are straight. Right? So this side, think about this. Okay, let me draw this small actually. You know, think about it in life. Maybe we have a leaf, right? The leaf looks like this. So what do? We put this piece of leaf on the coordinates. Then we can think about, because the left and right are straight, we can think this is the value on x-axis, right? On x-axis. Then we can treat the top as a function, the bottom also as a function. Then we're using our integration skills to find the area of this region or object. The idea will be still the same. You know, Riemann sum. We still do finite sum. So this is a finite sum expression. So what do? We're going to evaluate. Well, let's see this one. We're going to evaluate all those top rectangles by summation, because this is on top of x-axis, a positive value. So on top, positive value, and below, negative value. Then we find the sum of the bottom. We just subtract, right? We have the area above x-axis. We have the area below x-axis. We subtract them. So then we let n run into infinity. So that becomes integral. So the idea is still the same. So take a limit, let n run to infinity. So that become this notation, become integral, right? Integral from a to b, the top function, subtract the lower function. Because this summation sign is linear, the summation sign outside is the same as the summation sign inside. Okay, imagine we have area of this minus summation sign here, area of this, same thing, we cut it into n pieces. Because summation, when we add up things, right, it's linear, we can factor out the common factor. So we can just write it this way. One summation sign, you know, the changing in x is the same. Is a common factor, changing in x, the width of each rectangle. Only the difference is the height, right? The height we have f evaluate at a certain point, subtract g evaluate at the same point. So we can write this way, f minus g. So that's why we get area equals to, from a to b, the function on the top, subtract the function on the bottom, then dx. Right? The idea is the same, from finite world approximation to infinite world, to be exact. So from this picture also we could see the area of this. We find the area of this. Right? Think about it. We find the area of this. Then subtract area. Let me change the color. Subtract area of the. Oops. Subtract area of this, right? So f of x, right? The area here. Then subtract the area of g. All right. So that's the idea. We could write this way, or we could write this way. because we have integral from a to b dx are the same, right? So we can write just one time. Integral from a to b dx. Then the integral is f of x. The integral g of x we can write as one integral, f of x minus g of x. All right, so this is the method we're using to find the area in between of two functions. That requires the left-hand side and right-hand side to be straight. So we can put it on the coordinates. So let's see an example. So example 1, find the area of the region bounded above by y equals e to the x, right? Y equals e to the x. We know the graph goes this way, right? E to the x, exponential growth. Bounded below by y equals to x. So y equals to x. This, this picture is skewed. You see, 1 on the y coordinates is this much, but the 1 on the x coordinates is this much. So the graph is a little bit skewed. So y equals to x, and y equals to e to the x. We want to find the area between x equals 0 and x equals to 1. So we just set up the integral. Right? Integral from 0 to 1, from 0 to 1. The top function, e to the x, minus the bottom function, y to just x. So the integral is e to the x minus x, then dx. Then we enter derivative, right? We integrate. Integration of e to the x is still e to the x, is itself. Integration of negative x is negative half x squared. Then we evaluate at 0, at 1 we subtract them. So at 1 we have e to the 1 minus half. At 0 we get e to the 0, which is 1. So the second term becomes 0. So I have e minus half minus 1. That's e minus 1 half, or 3 halves. All right, simple, right? Okay, let's see 2. Example 2. Example 2, let's see what's different. Find the area of the region enclosed by parabola y equals x squared and y equals 2x minus x squared. We're not given lower limit and upper limit here, not like the first one. The first one we're given in between x equals 0, x equals 1. But here we do not have. But we do have region enclosed by. Enclosed by. So let's draw the picture. Y equals x squared, upward parabola. Y equals 2x minus x squared, downward parabola. Right? Downward parabola. And we see from the picture we have they intersect at 0, 0 and 1, 1. This is with the picture. Well, without the picture, what do we do? Without picture, we see enclosed by two functions. That means we need to find the intersection. So how do we find the intersection? Intersection means they have the same points, right? So that means, oops. That means that's the same point. That means we can equal them. So we would equal x squared equals to 2x minus x squared. They share the same point. That means at the point that intersect, those two functions are the same, are equal to each other. Then we solve for x. So x squared equals to 2x minus x squared. So we have 2x squared minus 2x equals to 0, right? So I move both terms to the left-hand side. Negative x squared become positive. So I have 2x squared. 2x move to the other side become negative. So I have 2x squared minus x equals 0. Divided by 2. I have x squared minus x equals 0. then factor it out. So basically, this is solve quadratic equations. So I have two solutions: x equals 0, x equals to 1. Right? So sometimes it's difficult to draw pictures, or right? So for this one, it's easy to draw the picture because it's just upward parabola, downward parabola. And sometimes it's difficult to draw the picture, so we could solve algebraically, find the intersection points. So this, right, so set those two functions equal to each other, we solve for x. X equals 0 and 1. That means those two functions intersect at x value equals 0, at x value equals to 1. So that becomes our lower limit and upper limit. So we can set up the integral from 0 to 1. Now we need to figure out which one is on top, which one is on the bottom. So the top one, obviously, in this picture is 2x minus x squared. So this we treat as f of x. Then y equals x squared is g, right? It's a lower one, so g. So we have f minus g. We have 2x minus 2x squared, 2x minus x squared minus x squared. Then so we integrate this definite integral. We integrate, so in the end we get a 1/3. All right, so you may ask, what if sometimes it's difficult to draw the picture? I don't know which function is on the top, which function is on the bottom. So if we switch this integral, we will get negative 1/3. We will get negative 1/3. If we do x squared minus 2x minus negative x squared, we would get a negative value. So if it's sometimes difficult to draw the picture, just take one, just guessing one as f, another one as g. In the end, if the value is negative, you just flip, f and g. All right, so this is the second example. I find the region enclosed by two functions. Sometimes we may have a shape like this. Or the y value, we have an integral, c to d. The left-hand side and the right-hand side, we can consider as a function of y. So this is another situation. If in this situation, we just cut the rectangle horizontally, right? If we flip this 90 degree, the idea is still same as before. So this we will cut from c to d infinite many pieces. So we will set the integral as from c to d, we cut y-axis. We're cutting y-axis as infinite many pieces. Then we have the right-hand side, minus the left-hand side. Okay, we're treating this x as a function of y, this x as a function of y. We would have the right-hand side minus the left-hand side. Let's see this example. So we want to find the area enclosed by those two functions. One function is a linear function, x minus 1, this one, and a parabola y squared equals to 2x plus 6. If we draw the picture, we get this. Draw the picture, we get this. If we don't have the picture, what do we do? If we do not have the picture, what do we do? Let's see. If we don't have this picture, right? And we see this one is not a function of y in terms of x, right? Because if we square root, we get a y equals to plus square root of 2x plus 6, and then y equals to minus the square root of 2x plus 6. So this is not a function of y in terms of x, but this can be written as a function of x in terms of y. So we could do x equals to, we could solve for x. X equals to half of y squared plus 3 or minus 3, right? It's not a function of y in terms of x, but it can be written as a function of x in terms of y. So we move 6 to the other side, we have y squared minus 6. Then we divide by 2, so we have half y squared minus 3. And also this one, we have to rewrite also. So we would rewrite this function. Y is a function of x, but we have to be consistent with this one. So we want to write that x equals to y plus 1. And the area enclosed by this, right? Then again, we want to solve the intersection. So how to solve the intersection? We set these two x equal to each other. So we have a half of y squared minus 3 equals to y plus 1. Then we solve for y. So let's multiply by 2, right? So we'll have y squared minus 2y, then plus 6, then, or minus 6, right? Because we'll multiply by 2, minus 6, then minus 2, it becomes minus 8. So we have this. Now let's factor this. So this can be factored as y minus 4 and y plus 2. So get a y equals to negative 2 and positive 4. Okay, so that's how we get those 2 points. We get negative 2 y value, right? Because y cannot be a function of x, so we just think, you know, x as a function of y. Then we just cutting along y-axis. So we set up the integral, right, from negative 2 up to 4. Then which one is on the left, which one is on the right? It's actually, for this one, it's easy to think, right? It's easier to think. You see, this is a minus 3. So this is positive slope. So we know this one is on the right. But in any case, if sometimes we have difficulty to tell which one is on the right, which one is on the left, we just subtract. In the end, if we get a negative value, we flip. We flip the two integrands. We flip the left and right. But for this one, so we have the right one subtract the left one. So the right one is y plus 1. The left one is a half y squared minus 3. So subtract those two. Then we simplify. Then we anti-integrate, anti-differentiate, or integrate. We get this. Then we evaluate at lower limit, at upper limit. We subtract them. We get 18. Right. You see the process is the same. Just one way to think. Whenever we cannot think of y as a function of x, okay, we can think x as a function of y. Then we have to cut along y-axis. So we would set up the integral lower limit, upper limit are y values, and the dy. We're cutting along y-axis, right? Cutting along y-axis into infinite many pieces. Any questions? All right, let's see more. Oh, one more example. All right, let's try. Okay, let's try this 4. Try 1 to 4. The first one is not given, right? It's not given. It's, well, actually, just according to the pictures, all right? Because you have these pictures, you know the lower limit, upper limit already. Hopefully some of you can show your work. Okay, Raphael. Maybe 3 more people. Some of you hasn't presented much yet. Remember, 30% of your grades come from the presentation. The first one we see, right, Raphael is going to present, right? It's easier to see. We can cut along x-axis. Second one also, we can cut along x-axis. But third one, we may not be able to cut along x-axis, right? So we cut along y-axis. We cut along y-axis. Cut along x-axis. We need to figure out the value of a and b on x-axis. Okay. Cutting along y-axis, we need to figure out the lower limit, upper limit on y-axis. Then on x-axis, we just have top function subtract lower function to be the integrand. Top function subtract lower function for the integrand. Cut along y-axis, we have the right function subtract the left function as integrand. Right, the right function subtract the left function as integrand. Okay, we have 1, 4. Anybody like to show 2 and 3? Okay, Raphael, we can start with you.
Okay, did you make me presenter?
I think so. Let me check. Did I? Yeah.
Awesome. So we start out with the two functions, right? 5x minus x squared and y equals x. So what we do is we take the integral, or we evaluate the integral over 4 to 0. And the reason why is because we have the intersection at 0, 0 and 4, 4, and we could assume that that is the origin on the graph. So we could just put that as 0, 0. And then we just extract that x value as the lower bound. So then we get to 4 to 0, 4x minus x squared dx. And the reason why is because we subtract the two functions, right? We have the upper function minus the lower function, which is, and then we take the integral of that, which is negative 1/3 x cubed plus 2x squared, evaluated over 4 to 0. And then we basically just evaluate that. And then in line 2, you can see that I evaluated from 4 and then subtracted f of 0. And then we get negative 64 over 3 plus 32. which, you know, if you convert 32 to a fraction over 3, it would be 96 over 3. So I just made it a little bit easier for the I to make it 32 over 3 units squared. I mean, we weren't given any units, so.
Okay, great. Yeah, just 32 over 3 so far, which is only pure mathematics. Yeah.
Yes.
Great. Good job, Raphael.
Thank you.
Mm. Okay, Noella. And yeah, anybody else do 2 and 3? It's good time to earn your presentation credits, right? Let me see. Labiba, do you want to try? Stanley, do you want to try? Oh, okay. So we need a little more time. That's fine. Okay. Oh, more problems to show. Yeah, I'm going to assign more problems. Yeah, Noel, I see your paper. I see your screen.
Are you able to see it?
Yeah.
Okay, so for number 4, I did the right function minus the left function. So in this case, it would be 2y minus y squared minus y squared minus 4y times dy. And from there, I simplified the terms of the two functions subtracting each other. And from there, I got the integral from 0 to 3 of y minus 2y squared times dy. From there, I found the antiderivative, so which would give us 6y squared over 2 minus 2y cubed over 3, and from the interval 0 to 3. From there, I did f of b minus f of a, and I got 27 minus 18, which is 9, and that's the area of the shaded region.
Great. Yeah, simple, right? Okay. Thank you, Noella. Okay, anybody else wants to try? Jason? Ursa? Stanley? Tanzania? Sophia? You guys need to present to get a presentation grades. That's 30% of your grades. You know, if I'm confusing you with the material, you know, let me explain more. Okay, Sophia, let me make you presenter. Oh, can you try to see which part you don't get it? Okay, let me put up a 3. Okay, let's see 3, right? 3, Sophia, do you think we should cut along y-axis or x-axis?
Along the y?
Along the y, right? Okay. What's the lowest value of y?
0, if I'm not mistaken. Oh, -1.
-1.
Uh-huh.
Okay, that's the lower limit, right?
Uh-huh.
So what's our upper limit?
1.
1. So now, so far we have this. We have integration. We're cutting along y with y from -1 up to 1. We have this, right?
Yeah.
The formula says use the red function, subtract the left function. What's the red function? Function of x in terms of y. Do you see this x is the function in terms of y?
Yes, yes.
So e to the y, right? So the integral is e raised by y. Subtract. What's the function of x in terms of y on the left?
Y squared minus 2.
Y squared minus 2. So minus, because we're minus the 2 terms, let's put parentheses around. Or minus, because we're subtracting 2 terms, so put parentheses around. That's y squared minus 2. Does this make sense?
So then wouldn't it be e to the power of y minus y squared plus 2 dy?
That's right. Right. If we take out the parentheses, so this term becomes plus. Then we just anti-differentiate. So let's integrate. So when we integrate the e term, what is it?
E to the power of y.
E to the power of y.
Yeah.
So let's write here. So let's anti-differentiate or let's integrate to get e to the power of y. Now, how do we anti-differentiate y squared?
I don't know. I did minus y to the power of 2 plus 1 over 2 plus 1.
Right. What's y? Right. Right. That's a power.
Yeah.
Okay, then
Plus 2y.
plus 2y. So minus 1/3 of y cubed, right?
Uh-huh. Wait, where'd you get 1/3 from?
So the anti-differentiation power rule is saying add 1 to the exponent divided by the new exponent.
Oh, okay, I see.
Plus 2y. Then we want to evaluate, right? We want to evaluate at -1 and at 1.
Yeah, 1 and -1.
Right. So the 1 that just becomes e to the 1 is 1.
E to the power of 1. Oh.
Right. E to the power 1 is e, right?
Mm-hmm.
So e minus 1/3 plus 2.
Yeah. Plus 2 times plus 2 times 1.
1, right? Still 2.
Minus e to the power of -1.
Right, minus e to the power -1, which is 1 over e.
Mm-hmm.
And
Minus -1 to the power of 3 over 3.
what is that?
1, no?
What's -1 to the power 3?
Right. -1.
-1. What's -1 times -1/3?
-1. 1 second. -1 times. Oh, -1 times.
Last one, right? Then last term, 2 times -1. What's 2 times -1?
-2 times -1. 2 times -2.
-2.
Yeah.
All right.
And every time I can't even do multiplication. I'm really bad, like talking, like.
Rest is just simplify this, right?
Yeah.
So I have e minus 1 over e, then just a number. The number will have a -1/3, -1/3.
Mm-hmm.
What do we have?
Then
-2/3.
wouldn't
Then we'll have +2 minus
-1. Yeah.
it become +4. So just simplify those two numbers.
Mm-hmm.
What's 4? Can you do 4 minus 2/3?
So then it'll be to continue on e minus -1/3 plus 2.
Oops. Right? So just simplify this. So this just becomes plus 1/3. Okay, does this make sense?
Yeah, a little. I'm getting
All
it.
right. Okay. Just keep practicing. So this is a 3. I think Noella wants to show 4, right? Or maybe someone can do 3. Oh, 4 is already showed. 4. 4 is already showed. Okay, yeah. Okay, 2 is only. Okay, Henry wants to do 2 together. Let's do 2 together. So 2, let's see. We have x, you see here, because this region, the x is good, right? From 0 to 2. So right away we get upper limit and lower limit. So lower limit is 0. And this one we see we can cut along x-axis. Okay? So we cut along x-axis. Because you see x, right? So lower limit is 0. Upper limit is 2. Right? 0 here, 2 here. So we get lower limit and upper limit. Now, what is the top function? Square root of x plus 2. So square root x plus 2. Because this function on the top, x plus 2. This is the f. What about the lower function? Lower function is 1 over x plus 1. So we do minus 1 over minus 1 over x plus 1. Then what anti-differentiate. So this is set up. Oops. Okay, so lower limit is 0, upper limit is 2. And then we're cutting along x-axis. The top one is y equals the square root of x plus 2. So the integral is square root of x plus 2 minus the lower one. The lower function is 1 over x plus 1. So minus 1 over x plus 1. Right, now let's integrate. Remember, this is raised x plus 2 raised by half. So we add half to it. We add half, that becomes, we add 1 to the half, that becomes 3 halves. Then we divide by 3 halves. Divided by 3 halves, the same as multiply by 2 over 3. So we have square root. I'm going to write, okay, square root of x plus 2 raised by 3, right? 3 halves. Or I don't need a square root. Let's do this. Raised by 3 over 2. So the first term will not anti-differentiate. I get a 2 over 3 x plus 2 raised by 3 over 2. Because this integral is x plus 2 raised by half. I add 1 to half, I get 3 over 2. I divide it by 3 over 2. It's the same as multiply by 2 over 3. So that's my first one. That's my f. Subtract g. 1 over x plus 1. That's ln minus ln of absolute value x plus 1. Right. Let's check our interval. Our interval from 0 to 2. So x goes from 0 to 2. Ln of x plus 1 will be positive. So I don't really need this absolute value. But be careful. Be careful with that. Sometimes because it's depends on the upper limit or the lower limit. So in this case, x plus 1 is positive from 0 to 2. So I don't need absolute value here. So this is my antiderivative, right? Let's evaluate at 0 and at 2. Let's evaluate at 2. So evaluation at 2, so I have 2 plus 2, that's 4. 4 I can write as 2 square. Square cancels this half, so I have 2 raised by 3. That becomes 8. 8 times 2/3 is 16 over 3. Right, then minus ln 2 plus 1 ln 3. So that's my evaluation at 2. But what about at 0? Subtract at 0. At 0, I only have 0 plus 2, that's just 2 raised by 3 halves. Right? 2 raised by 3 halves can be simplified as 2 square root of 2. Or 2 radical 2. That becomes a 4 radical 2 over 3. 4 over 3 radical 2. So 4 over 3 square root of 2. Then 0 plus 1 is 1. Ln 1 is 0. So this should be the final answer. Ln 1 is 0. So we have 16 over 3 minus ln 3. We don't need to approximate this value. Keep as ln 3. That's exact. Minus 4 over 3 square root 2. The square root 2 again is another irrational number. So we have 2 irrational numbers, ln 3 square root of 2. We just keep them. That's exact form. We don't have to approximate. All right. Any questions for this one? Okay, let me give you a couple more questions to do. I don't want to do that. Make this small. Okay, let's try. Let's try. Okay, 5. 5 is very similar to the example. 9. Let's try these two, 5 and 9. Okay. So next class, let's try those. Eleven to 17. Okay, let's try 5 and 9. Okay, Alexandra wants to try 5. Then I will need somebody to try 9. Alexandra, you can get yourself ready. Let me make you presenter. Alexandra, can I hear you? Are you speaking?
Oh, hi. Could you see my work?
Yeah.
Okay. Because it's taking me a while to see it on the screen, but I can explain it from
Okay, thank you.
on my iPad.
Okay.
So we're given y equals e to the x and y equals x squared minus 1. And the domain I found was from -1 to 1. And I kind of just sketched it. So I already know the region that we have to fill. So I found the integral from -1 to 1 of the upper function, which was e to the x, subtracted by x squared minus 1, which is the lower function. And then I found the antiderivative. So antiderivative of e to the x is just itself, e to the x. And antiderivative of x squared minus 1 would be 1/3 x to the third plus x, because you distribute the subtraction sign. And then that's from -1 to 1. So then I plugged in 1 for +1 first, and then subtracted by the second number, which was -1 in each function. And then I simplified that, and then I had eventually gotten e minus 1 over e plus 4 over 3.
Great. Looks great.
Okay.
Thank you. Anyone has any question? All right. So anybody like to try 9? Nine, we see we have a function of x in terms of y, right? We're not given upper limit or lower limit, so we have to solve for it. we set the two equal to each other, right? Then we solve for y. So basically, we're cutting along y-axis. We need to figure out which one is on the right, which one is on the left. Right? We can graph it. We will have this kind of graph, right? This kind and this kind of graph. One is a parabola to the left, one is a parabola to the right. Oh, sorry. Okay, I was talking about 9, right? 9, we see x is a function of y. X is a function of y. So how do we think about this? We can flip. You see, let's see 3, right? Let's see graph of 3. And of course, this one is not a function. X equals y squared minus 2. In pre-calculus, this is not a function because this would fail the vertical line test. But however, we can think this as a function of x in terms of y. Why? We flip. Let's flip the xy. Let's flip this graph 90 degrees. Let's rotate. Let's rotate this whole thing 90 degrees. Right? If we rotate this 90 degrees, we see we have this graph. We see this parabola becomes like this. Right? And now we have this part, and this part becomes like this. Oops. Becomes something like this. Right? This does not go that lower. Does this make sense? So in that case, we can still talk about, now this is our x-axis. Now this is our y-axis. And when in pure mathematics, who cares about x and y? That's just variables, right? If I like, I can change this x to be y. I can change this y to be x. So I can still talk about, x is a function in terms of y. That's the idea. So 9, we see x is a function of y. X is a function of y. And we're not given upper limit, lower limit. So what do? We need to solve the region enclosed by those two graphs or by those two functions. So we set them to equal each other. We have 1 minus y squared equals to y squared minus 1. Right, let's try this one together. Unless someone wants to try it. Oh, I do? Okay, anybody? Oh, Kizer, go ahead. That's great. Okay, good. Kizer, I see your screen. Go ahead. Looks beautiful.
So for this one, so first I set the equations to each other to find where they cross, the points where they cross. So I set y minus y squared equal to y squared minus 1, and I combined them and made them into one function. So 0 equals 2y squared minus 2, and then I factored and got 2y minus 1, y plus 1, and y equals 1 and negative. So I can evaluate the integral. To find the area, I can use the integral from -1 to 1 of 1 minus y squared minus y squared minus 1. So then I get 2 minus 2y squared dy, and then I evaluate and get 2y, 2/3 y cubed bar -1 to 1, and I sub in and get 8/3 as the volume. 8/3.
Okay, let's see. Okay, so you evaluate 2y at 1 and -1. So minus minus become plus. So that's why you have 2 plus 2. Minus minus become plus. So great. Looks great. Beautiful work. Anybody has any question? Okay, so kids, okay, leave the screen. Hannah wants to explain the part about rotating the graph 90 degrees. Okay. So to think about x as a function of y, right? It's kind of weird. It's kind of weird, right? If that doesn't make sense for you, because if you think about pre-calculus is saying, I cannot talk about those two as functions, right? Because they fail the vertical line test. Have 2 points intersect with this vertical. That's the idea of pre-calculus. But right now, we can talk about x as a function in terms of y. Why? Because we can rotate this plane 90 degrees. We rotate 90 degrees. When we rotate, you see this picture rotated 90 degrees, then this x-axis becomes y-axis. This y-axis becomes an x-axis. So that's still, you can still think that's y as a function of x. Don't trouble yourself, okay? Just think, okay, I cannot talk about these two curves, these two graphs as functions of y in terms of x, but I can think of them as a function of x in terms of y. All right, if it's confusing, just think that way. Just forget about the vertical line test. Just think as x is a function of y. And you know, we can cut along x-axis, we can cut along y-axis. If we have function y in terms of x, we can cut along x-axis. If we can make a function of x in terms of y, we can cut along y-axis. Does it make sense, Henning? Okay, all right. All right, any other questions? Okay, thank you, Kaiser. Beautiful job. Let's try one more. Okay. Okay, let's try one more. Let's try 10. We don't have much time. We have 10 minutes. Let's try 10. 10, again, we see we cannot write y as a function of x. But we can write this equation as function of x in terms of y. So I'll leave 11 to 17. Maybe 11 to 18. 18 involves absolute value. Okay, I'll leave this couple for next class. So for now, I'll try 10. 10, we have to cut, we're limited, we're constrained, we have to cut y-axis, right? Because the first equation, we may not write y as a function in terms of x, but we can write x as a function in terms of y. For this one, we can set them to equal to each other. You know, if we solve for x, we set them to equal each other, or we can use the second one. The second one is saying x equals y, right? So we could substitute this x into y. Then we get y squared plus 4y minus 12 equals 0. Then we can factor from there. That would be a quick way. Because we're trying to find the intersection of those two graphs. Anyone like to try 10? So my hint is to substitute y into x. So the first equation we can write as a y squared plus 4y minus 12 equal to 0. And then we can factor this. Can factor as y plus 6 times y minus 2. That means because we're going to cut along y. Because the first equation we may not be able to write a y. So the first equation not given us y as a function of x, but we can think the first equation as a function of x in terms of y. So that's why we're trying to solve for y. So y equals to -6 and 2. That's our lower limit and the upper limit. So once we have this, we can we set up our integral. From -6 up to 2. What's our integrand? Our integrand is left subtract the right. We don't really care. As I said before, sometimes it's difficult to tell left or right. We just do this. We just do the first one, we solve for x. So when we solve for x, what do we get? We get a 12 minus y squared, right? 12 minus y squared divided by 4, we have 3 minus 1/4 y squared. Then minus y, then dy. We do we integrate this definite integral. If we get a negative value, we just switch. Switch, we do y minus 3 plus 1/4 y squared, right? So we integrate this. So I'm not able to finish. We only have 1 minute left. So just integrate this integrand, right? So 3, we get 3y. Then y squared will become y cubed term. So we get minus 1/12 y cubed minus y squared divided by 2. Then we integrate, then we evaluate at 2. We evaluate it at -6. We subtract them. All right. So I leave 11 to 18 for you to practice. Right? And any questions? Okay, see you on Thursday then. Thank you. See you on Thursday.